Good morning, students. Today we are going to learn a new chapter, and the name of the chapter is Quadrilaterals. So, what do you basically mean by quadrilaterals? So, quadrilaterals, quad stands for four, and laterals means shape. So, any four-sided shape is known as the quadrilaterals. So, today we'll learn how many types of quadrilaterals are there and what are their properties. So the first one, the very simple one, is the square. A square has four lines of symmetry. So symmetry means it is a line through which equal parts of the shape can be folded. Now for example, if this is a square, this is the line of symmetry, means along this line these two equal parts can be folded. So similarly in a square it has four lines of symmetry. So this is the first line, second line, third, and this one is the fourth. So we can say a square has four lines of symmetry. It has rotational symmetry of order 4. That is, if rotated about the center, it will land back on itself 4 times. Now it has rotational symmetry. Rotational symmetry means if we rotate any object and it will look exactly the same. Now if this is a square, if we rotate this one, or you can say this A to the point D, if rotate in this manner, so if we rotate 4 times, so it will be like as the same square. So we can call as a square, it has rotational symmetry. A square has four equal sides, so all the sides of a square are equal. Opposite sides are parallel in a square. See, these two are opposite sides, so opposite sides are equal as well as parallel. Similarly, these two opposite sides are also parallel. All corners are 90-degree, so all corner angles are have the measure 90-degree. Its diagonals are equal, so diagonals, so AC and this BD both are equal. Diagonals bisect at 90-degree. Now see, these two diagonals, they bisect in such a manner that all the angles are equal to 90-degree. And area of a square is length into length, or we can say if this is a side, we can call area of a square as side into side. Next we'll come to rectangle. A rectangle has two lines of symmetry. So we can fold the rectangular in two parts in two lines. So this is the first line. Oh no, this is the first line and this one is the second line. So it has two lines of symmetry. It has rotational symmetry of order 2. So it can be rotated in the order of 2. In two ways it can be, or we can say in two rotation it can be rotated such that the shape exactly looks like the same. A rectangle has two pair of equal sides. So a rectangle has, now you can see in this figure, these two are pair of parallel sides. Okay, so these are the opposite sides and these are parallel. Similarly, we can see here these opposite sides are equal as well as parallel. Opposite sides are parallel. All corners are 90-degree. Like in the previous square, in rectangle also all the corner angles are equal to 90-degree. Its diagonals are equal in length. In a rectangle, the length of both the diagonals are equal. That means AC is equal to BD. Diagonals bisect at the center. So these two diagonals will intersect at a point, and that point is the center of the rectangle. Area of rectangle, we know it is length into breadth. Length is the longest side of rectangle, whereas breadth is the shorter side. So area of rectangle is length into breadth. Next will come rhombus. So this is the figure of a rhombus. A rhombus has two lines of symmetry. So we can fold a rhombus in two ways. One is this one, other one is this one. It has rotational symmetry of order 2. So a rhombus can be rotated in two orders. Okay. A rhombus has four equal sides. So in a rhombus, all the sides are of equal measure. It is just similar in case of a square, but the difference is that in a square, all the corner angles are equal to 90 degree, whereas in case of a rhombus, angles are, or we can say the corner angles are not equal to 90 degree. Opposite sides are parallel. So these two opposite sides are parallel. So these two are also parallel. Top and bottom corner, same size and side angle are the same. Top and bottom corners. So this is the top and this is the bottom. So this angle is equal to this angle. Similarly, this angle is also equal to this angle. Its diagonals are equal. So both the diagonals of a rhombus have the equal measure. Diagonals bisect at 90 degree. So the diagonals will bisect in such a manner that all the angles will be equal to 90 degree. Or we can say all the angles are equal to right angles. Next will come to a type of quadrilateral called as a kite. So this is the shape of a kite. A kite has one line of symmetry. So unlike in rhombus and rectangle, this shape has only one line of symmetry. It means we can fold the kite along the line of symmetry in two parts in only one line. So this is the line. So along the line AC we can fold the equal parts of a kite. No rotational symmetry. So no matter how much we rotate a kite, it will never resemble with the original shape. So we can say a kite has no rotational symmetry. A kite has two pairs of equal sides. So you can see in a kite, these two pairs have the equal side. That means AD is equal to AB and CD is equal to BC. Its diagonals are equal. Now the length of AC is equal to length of BD. So the diagonals have the equal length. Diagonals bisect at 90 degree. Now these two diagonals will intersect and in such a manner that all the angles are equal to 90 degree. So this all angles are equal to 90 degree. Next, parallelogram. A parallelogram has no line of symmetry. So we cannot fold a parallelogram across any line. So it has no lines of symmetry. It has rotational symmetry of order 2. So it can be rotated about in order 2. A parallelogram is a quadrilateral which has two pairs of parallel sides. One pair of edges is longer than the other. So if suppose this is a parallelogram, these two are parallel and similarly these two are also parallel. So one pair of sides, or we can say one pair of parallel sides are longer, whereas the other pair of parallel sides are shorter. All the interior angles add up to 360 degree. So all the interior angles of a parallelogram, if we add all together, it will sum up to 360 degree. Its diagonals bisect each other at the center of rotation. Now, the diagonal will bisect each other at the center of rotation. That means the diagonal will bisect each other at a point, and that point is called as the center of rotation. Now, area of a parallelogram is length into perpendicular height. So length we can consider as the longest length into perpendicular distance, or we can say perpendicular height. So if we take this point as A, the perpendicular distance from this point A. So length into perpendicular height will give us the area of a parallelogram. And the last one is trapezium. It is similar like parallelogram. It has no lines of symmetry. So we can say trapezium has no lines of symmetry. Apart from that, trapezium also don't have any rotational symmetry. In case of a trapezium, it has only one pair of parallel sides. In the previous one we have seen in parallelogram, it has two pairs of parallel sides, whereas in case of trapezium, it has only one pair of parallel sides. Now, as you can see here, we have two diagonals. This is the shape of a trapezium. So BC and AD are the two diagonals. Now we can see here the two diagonals intersect at a point O. Now what happens? Due to the intersection of these two diagonals, we have these two different line segments. One is CO, OB, OA and OD. So the length of CO is equal to the length of OD, and similarly the length of AO is equal to length of OB. So this is a important property in case of a trapezium. It has diagonals, but they do not bisect each other at the center of the shape. So the diagonals of a trapezium, they do not bisect, or we can say they do not intersect at the center of the trapezium. Moreover, they intersect at a point which is closer to the shorter side. So in the next video, we are going to learn the properties of some more types of quadrilaterals, as well as formula of area and volume of quadrilaterals. Thank you.